Actually, not the salt bridge, because he's saying, actually, he's asking you to measure the E naught. So there's going to be, what would be the electrode made up of? What would the solution contain? Like this.
Solution would contain water.
Okay, so there is water, obviously. And what are the ions? There's going to be H+1 ions in the water as well,
Yes.
right?
Yes.
And the concentration of this is going to be 1 mole per decimeter cube, right? And
Yes.
what would the electrode be made up of?
Platinum.
So the electrode over here would be made up of platinum. You're going to label that this is platinum electrode. And what would you measure the potential with? Like, what would be the other electrode? I mean, whenever you measure standard potentials of a
Hydrogen.
so you measure it against a hydrogen electrode, which is again going to be H2 gas, and there's going to be H+1 ions in solution concentration, and there's going to be platinum electrode, and you're going to connect them together. That's with a voltmeter. There's going to be a voltmeter in the middle, and there's going to be a salt bridge, right? Is that clear?
Yes.
So label everything, tell them that this is 1 mole per dm cube. The H2 gas is 1 atmosphere pressure, and this is a platinum electrode. So that's the first part. So remember, drawing electrodes, and that's a 4-mark question. You get big questions on drawing electrodes. Is that clear?
Yes.
And then you have, for the cell drawn, use the data booklet to calculate the E naught cell and deduce which electrode is the positive one. So we've drawn this cell. I know this one is the 0 voltage, right? That's my reference electrode, right? So that is 0 voltage. I just need to open the data booklet and see and find this equation over here. The O2 with H+1, and so it's going to be probably this one, O2 plus, what was the equation? Just a second. So the equation was, where's the equation? O2, 4H+1 plus 4 electrons to H2O. So it's probably this one, O2 plus this equation over here, and that's 1.2. That's 1.23 volts, right? So so this one over here is 1.23 volts. So you've got one potential here, 1.23. The other one is 0 volts. So the potential on the electrode is obviously going to be 1.23, higher potential minus lower potential. And which one is the positive one?
Higher will be positive.
So that's it. And this?
That's negative.
Yes. So he did ask us to find out which one is the positive one. So identify the positive electrode. So it's the one that's on the right side. And the E naught cell is 1.23 volts. For the cell, so he's specifically asking about the same cell. Now this one is use the data from the data booklet to predict whether the reaction is feasible when an aqueous solution of acidified hydrate 5 and bromide ions are mixed. Explain your answer. Now remember, how do you calculate E naught cell? Like, what's the
higher potential minus lower potential?
Okay, so he's saying the reaction is between iodate 5 ions and bromide ions. So I'm going to pick the equation for bromine, which is Br2 plus 2 electrons in equilibrium with. I mean, bromide ions, you only have one equation, and that's, I need to look up the value. So for bromine, you got this equation only 1.07 volts. So that one is, the E naught for this one is 1.07 volts. So who's going to gain electron? Who's going to lose electrons?
Bromide ion is gonna gain electrons, and Br2 is gonna lose.
Which one is the higher potential? It's this one, right?
Yeah, that one.
And this one is the lower E naught. That's the one that's going to lose electrons, right? So higher gains, lower loses. And but the question is this reaction feasible? So Who are your reactants? Your reactants are iodate ions, acidified, and the other reactant is Br -1. So he was asking for the same acidified iodate 5 ions. That's this one, acidified iodate 5 ions are reacting with bromide ions. So they are reacting, right? And is the reaction feasible? Now, they didn't ask you about the equation. I don't think they asked for the equation anywhere. So they didn't ask for the equation. So how would you say that this reaction is feasible? You're going to calculate the E0 cell, which is higher or higher minus. So it's going to be 1.19 minus 1.07. Make sure you use reduction minus oxidation instead of higher minus lower, because that will give you an idea of whether the reaction is feasible or not. So you're getting a positive value. So this is what you're going to state here, that the E0 cell is coming out to be greater than 0. That means the reaction will happen. Is this clear?
Yes.
Now the next one is, this is about the Faraday constant. We're going to do that. He's saying use the half equation to write the ionic equation for the electrolysis of Al2O3. So he's saying that this is the reaction. So we didn't do we did electrolysis, right?
We did.
We did, yeah. So he's saying it's Al2O3 getting electrolyzed. So this is the equation at the anode. Now, if you know Al2O3, what is going to be present at cathode, the negative side? It's going to be Al plus 3, right?
Yes.
So that is the one that's going to gain electrons. It's going to gain 3 electrons. And that's going to be your reaction at cathode. So what do? You just add up the two equations and you make the number of electrons equal. So what do I multiply both equations with?
3 and 2. You multiply O2, that equation, with 3, and the below one with 2.
And you just make the overall equation, which is going to be 3O minus 2 plus 3C, those plus 2Al plus 3, and the product is going to be 3CO. And at the bottom, there's going to be 2Al. That's your reaction. Now, the other thing is this one about the Faraday constant. What did we study about the Faraday constant? That 1 mole of electrons, they have a charge of 96. 1 mole of electrons, they have a charge of 96,500 coulombs, right? Is that clear? And we also studied the formula Q is equal to IT, that if you're given current and time, which we are given over here, so you can figure out the charge. And if you figure out the charge, you can figure out the moles of electrons that are passing through the circuit. So what is the charge in this case? It's what is Q? It's 3 hours, 3 into 60 minutes into 60 seconds into current, which is 3.5 into 10 to the power 5. So what do we get?
That's 3.78. 3.78
This thing, 3.78 watt.
grams. No, this is charge, coulombs.
You can't get 3.78 if you multiply all of this into 10 to the power something, or I mean, this thing will not give you 3.78.
3.78 times 10 to the power 9.
So it's, I don't think you can get 10.9. Maybe you can, but let me just try this. I don't think 10 to the power 9 is possible. That's 1 second, 3 point, maybe it is 3.78 into 60 into 60. So that's 36. Maybe you can. It's going up into 3.5. Yep, I think you can. And then so let's go with this 3.78 into 10 to the 9. I just had a desktop calculator, so that's not working properly. So we got this, right? And we can convert that into moles of electrons. So how do you convert that into moles of electrons? So 1 mole electrons got a charge of 96, 500 coulombs. So how many moles, how many coulombs do you have? You have 3.78 times 10 power 9 coulombs, right? So how many moles of electrons is that?
Three point 917.
How much?
3.9 times 10 to the power 5.
Into 10 to the power 5. So that is,
Sir, I think there's something wrong. Sir, just can you give me like 1 minute? I'll just get a new calculator.
okay.
Yes, 3.9 times 10 to the power 3.
10 power 3.
Yeah, 10 to the power 3.
So you're getting 3.9 times 10 power 3. And that's the moles of electrons. So you found the moles of electrons. So he's asking for the mass of aluminium. So aluminium needs,
Moles equals mass by molar mass.
no, but first thing is you have to find the moles of aluminium. We just found the moles of electrons, right? So the moles of aluminium are going to be 3 times less. So divide this by 3. So I think that would be, aluminium is going to have how many moles? It's going to have 1.3 times 10 to the power 3 moles, right? Is this clear? And then you multiply it by the MR, which is 27. So you'll be able to figure out the mass.
Okay.
So what are we getting?
$35,100.
So we're getting 35,100 grams. So is this clear that you get the moles of electrons? Once you find the moles of electrons, then you'll be able to find the moles of the other substance. Just
Yes, sir, I get it.
okay. The first step in the conversion. So I mean, you just have to write the equation. That's about it. You can do that. Define the term standard electrode potential. We did that. It's the potential difference that is calculated between a standard electrode and a standard hydrogen electrode. And again, you're being asked to draw a fully labeled diagram of the apparatus that would be used to measure the standard cell potential of this electrode. I mean, this is how they write electrodes. So there's an electrode. Remember this, like this equation. I mean, I should have stuck to the question just a second. I said, remember, there's another way of like a shorter version of writing electrodes. Like if I want to write this one, I'll just write silver ions with silver, right? Is that clear?
Yes.
So this is what they're doing over here. That they're asking you to write, draw the electrode. So this one involves a metal. So what type of electrode would that be? It's going to be?
Metal with aqueous.
Okay, so the AU would be the metal and the solution
That
will,
will be A3 plus.
will be Au3 plus. And the other one is nitric acid, aqueous, and it's a gas.
You need a gas drum.
And what's the electrode?
Electrode will be platinum.
It's going to be platinum. Like when you don't have a metal, then the electrode is going to be platinum. So that's, I mean, label everything. And you're going to have a voltmeter, and there's going to be a salt bridge. Did we draw the salt bridge in the last diagram? Yeah, we did. So the salt bridge is important. As anyways, we've made the diagram. That's pretty much it. And again, 4 marks. And then he's saying write an ionic equation to show that the spontaneous reaction that occurs when electric current is drawn from the cell. So what is the reaction that's happening? You had, which of the two equations? You had an Au and Au3 plus, so it was this reaction. And the other one was involving the NO gas with nitric acid.
Yeah.
So it's the third reaction, H+1 with NO3 -1, right? So it's basically a reaction that's happening between these two. Who's going to gain electrons? Who's going to lose electrons?
U3 plus is going to gain electrons and NO is going to lose electrons.
So there's a gain and loss of electrons. The electrons are equal. So it's easy. You can add up the reactants. The reactants are these. So it's the equation would be Au3 plus. The other one would be NO plus 2H2O. And the product is going to be, in the first one, it's going to be Au. And in the second one, it's going to be NO3 -1 plus 4H plus 1. So that's going to be your product. And then he says calculate the E0 cell for the reaction. So reduction,
Just subtract them.
which is
0.54.
0.54 volts. And then he says gold can be oxidized by a mixture of concentrated hydrochloric acid and concentrated nitric acid, which is known as aqua regia. The concentration of hydrochloric acid is 12 mole per dm cube, and the concentration of nitric acid is 16 mole per dm cube. Explain why aqua regia is able to dissolve gold. In your answer, state and explain what effect the use of concentrated hydrochloric acid and concentrated nitric acid have on the E values of half equations 2 and 3. So he's basically interested in equations 2 and 3, right? So let's rub all of this. This was for the previous part. First thing, he's using concentrated hydrochloric acid. So which reaction will be affected if you use concentrated hydrochloric acid? Which one would you use?
Second one.
The second one. And that means the CLN concentration is really high. So if it's really high, where would the equilibrium shift?
Towards the left.
So if it shifts towards the left, what will happen to the potential value for this reaction? Decrease or increase?
Increase.
See, towards the left, it's going to move towards the left. So
towards the left, it will decrease. Yes.
So let's give it some value, just some random value. Let's say 0.8 volts, right? So if it moves towards the left, more electrons are going to be produced, and the electrode will have a lot of electrons. So the potential would decrease. Now, what about concentrated nitric acid? So concentrated nitric acid, it's this one, right? So where would the equilibrium shift?
Towards the right.
Towards the right, right? So the potential over here will increase, right? It will become, let's say, 1.2 volts. Remember, it's not going to increase or decrease by a large margin. It's just going to slightly decrease or increase, right?
Yes.
So that's the first comment. You're going to state that this equilibrium shifts to the left and its potential decreases because of the higher concentration of CL ions. And this one, equilibrium number 3, shifts to the right and its potential increases. Now, why would gold dissolve? Like in the first one, look at the first one. The first equation cannot happen. Like gold, when you say gold dissolves, that means gold gets converted into ions, right?
Yes.
So the first reaction, who loses electrons? The one that has the lowest potential, right? But out of the three reaction, it still has the highest potential. Like even if you change their potentials, remember the potentials are not going to increase or decrease by a large margin. I mean, 0.2 is like probably the best thing that could happen to them. A change of 0.2, right? So the first reaction, in the first reaction, gold can never dissolve. It's got a higher potential, right? Is that clear?
Yes.
So that is out of the question. Gold cannot dissolve in the like if you use the first equation. What about this one? This out of the two, this one is the lower potential, right? And this one is the
Higher potential.
so that means the lower potential it loses electrons, right? And the higher potential gains electrons. So you can see gold is dissolving. Gold is turning into a complex ion, which is AuCl4 minus 1. Is that clear?
Yes.
So you're going to mention all of this. This is probably a 3-mark question. So you're saying in your answer, state and explain. The first thing would be the effect of using concentrated hydrochloric acid and concentrated nitric acid. And then you're going to state that since this is the higher potential, hence, I mean, you don't have to quote these reactions because the numbering is done already for you. So you can just quote that equilibrium number 3 will shift to the right or will gain electrons because it's the higher potential, or it will get reduced. And equilibrium number 2 is going to lose electrons because it's the lower potential. And you can write the overall reaction if you want to, just to be on the safe side. Is that clear?
Yes.
Now this one. Now remember, sometimes they'll make the equation for you and they'll ask you for the E naught cell. So the first thing is you would have to, like the overall equation is already made. You would have to figure out what the electrodes were. So you have I-1 and I2 electrode, right? And the other one is copper 2 plus. And what is the charge on copper over here?
+1.
+1, right? So it's 2 electrodes. One of them is the I2 I-1 electrode, which is 0.54 volts. The other one is the copper 2 plus and copper +1 electrode, right? It's probably these two electrodes that are involved. This one is 0.15 volts. This one is 0.54. So I'm going to just code those two reactions. So copper 2 plus +1 electron in equilibrium with copper 1 plus, and this is 0.15 volts. The other one is I2 plus 2 electrons and forming 2I-1. That is 0.54 volts. Now ignore what's going to happen, like who's going to gain electrons and who's going to lose electrons, right? I mean, ignore that. Look at the reaction. What is happening in the reaction? Copper 2 plus is turning into copper +1, right? Is that clear? So that means copper 2 plus is turning into copper 1 plus, and I-1 is turning into I2. So I-1 over here is turning into I2, right? So this is how they're stating that the reaction is happening. Is that clear? Now, do you think this is how the reaction should have happened by looking at the potential values? I mean, is this correct? Like this, is this supposed to lose electrons?
No, because that is the higher potential.
Right. So I mean, so basically this equation is wrong. I mean, this is not how it's going to work, right? So is that clear?
Yeah.
So he did everything wrong. But how can you state that? He's asking you to measure E naught cell, which is why I was always telling you to how to measure E naught.
Reduction potential minus oxidation potential.
So the reduction potential is 0.15, right? Because
Yes.
sometimes they're going to do things incorrectly. So the E naught cell, I mean, if you had measured the E naught cell as higher minus lower, you would still get a positive value. That wouldn't make sense. But now you're going to get a negative value. This is the reduction potential and this is the oxidation potential. So it's going to be minus 0.54. And if you subtract the two, you're going to get minus, I think, 0.39.
Yes.
So you're going to get minus 0.39 volts, which is a negative value. The negative value indicates that all you've done over here, it should be done in the opposite direction. That's what negative potential indicates. Is that clear? So that means, so this indicates that the reaction is not feasible. So he's saying, explain how the value of E naught cell calculated predicts that the reaction is not likely to occur because it's less than 0. I mean, you're going to, E naught cell is coming out to be less than 0. That indicates it's not feasible. So is this clear?
Yes, sir.
So next one is, now he's asking you to use the Nernst equation to calculate the electrode potential for the copper 2 plus copper plus, which was, we already did that. It's written over here, copper 2 plus, copper 1 plus. And he's given you the concentration of copper 2 plus ions and the concentration of copper plus 1. So what was the Nernst equation? It was the new potential is basically E naught, which is the old potential, which is 0.15. So we are doing this, which is 0.15 plus
0.059
divided by
moles.
Z, that's number of electrons, right? And
Yes.
log of oxidized species. So which one is the oxidized species out of the two?
The first one.
Yes, that's the oxidized species. So copper 2 plus concentration, that's 1 mole per dm cube, divided by the other one, which is 1.3 times, I think it's 10 power minus 6, I guess. So 10 power minus 6. So that is, you're going to calculate, and you should be able to predict this as well. So he's using a very small concentration of copper 1 plus. So would the potential be higher or lower? Like if you use a very small value of, where would the equilibrium shift? It's going to shift in the forward direction. Would this be,
forward direction.
so would this be higher or lower?
This will be higher.
So this is going to be higher. And yep, that's going to be higher. And the other thing is, so calculate this value. What do you get for this?
0.497. 0.50. Yeah, 0.50.
So you're getting 0.50 volts, right? So this one changes to, so this one changes to 0.50 volts. And he's saying copper 1 chloride is also sparingly soluble in water. So, I mean, that question I think is over. He's saying copper 1 chloride is also sparingly soluble in water, suggests why the following reaction does not occur. I said, no, we didn't study the whole question. He's saying a reaction does occur under these conditions, right? Like if you use these concentrations. So the reaction will happen because now the difference is like really small. I mean, you can just increase the concentration of I minus 1 slightly and this would become a lower potential. Is that clear? So, I mean, if this is 0.50 volts and this becomes, let's say, 0.45 volts, then this will gain electrons, this one would lose electrons, and the reaction is going to become feasible. So, in this case, he's saying the reaction will happen. But then he states that when you do the same reaction with chlorine, and even if, and he's saying copper 1 chloride is also sparingly soluble, suggest why the following reaction does not occur. So now he's saying you do the same reaction with chlorine. Like instead of I minus 1, instead of that, you have, I mean, everything is the same. It's the same reaction, except instead of I minus 1, you've got chlorine, right? So he's saying no matter what you do, the reaction doesn't really happen. So if I have Cl2 instead, that is 1.36 volts. So even if this becomes 0.50 volts, right? It's still going to be lower than this one. Is that clear?
Yes.
So the gap between the two electrodes is a lot. Like this is 0.15. Like you can ignore the iodine one. So this is 0.15. This is 1.3. So that's a huge gap. Like by just changing the concentration, you can't make the lower one the higher one and the higher one the lower one. That would not be possible. So is this clear?
Sir, can you please repeat the last part?
Yeah, I was just saying that why did the reaction become feasible with iodine? Because the gap wasn't very big. Like this is 0.15, this is 0.54, right? So by
Yes.
changing the concentration, you were able to make it into 0.5 volts, and it would eventually become the higher potential. And you can just change the concentration, tweak the concentration just a tiny bit, and this one would become the lower potential, right?
Potential.
So the reaction would become feasible. The higher potential would gain and the lower potential would lose, right? But when you do the same thing with chlorine, uh, the reaction is not going to happen. And the reason for that is this is 0.15 volts and this is 1.36 volts. So that's a huge gap. And you can't change concentration that much to make this into the higher potential. Like even if you do a lot of change in concentration, even still, it's not going to become greater than 1.36. Is that clear?
Yes.
So the point is that the reaction will not happen because Cl minus 1 electrode potential is very high. And it will always be the higher potential and it would always gain electrons. It's not going to lose electrons. So that's the answer to this. I don't know what wording would they use, but that should be enough. That I mean, I'll just quickly 1 second 9701. What's it's M19 MS42. So just the that's wait. So they're talking about the E naught cell that it's so they're talking about the E naught cell being I mean that would have worked. I mean that would be the same thing, but they were specifically quoting the E naught cell that it's very negative. Like if you do high minus low, it's I mean the potential gap is really large. So I think you should have quoted the E naught cell instead. Is that clear? I mean this one.
Notice that the E naught cell is very negative.
It's very negative, yes.
Okay.
Okay, so I think whenever you have whenever they're asking about the feasibility of reaction, it's better to quote the E naught cell instead of just describing why the reaction will not happen. It's better to quote the E naught cell. And the other part is you can construct the equation for the reaction. All you have to do is balance the equation. It's so these two are I think reacting. So it's ClO3 minus 1 with SO2, and the product formed is ClO2, and the other one is SO4 minus 2. So you just have to figure out the oxidation states, which are this is +5, this one is +4, this one I think is +4, and this is +6, I think. So sulfur gains how many electrons or loses how many electrons? Like how many electrons are gained or
It
lost by?
loses 2 electrons.
What about the other one, +5 to +4? That's
It gains 1 electron.
so it gains 1 electron, right? So all you have to do is multiply which one by what,
Multiply that by 2. You multiply ClO3 by 2.
and
That
that's about it.
equation, yes.
The oxygens will probably get balanced. It's going to be 6 + 2 8. 4 plus 4, that's 8. So that's fine. What is meant by disproportionation? When the same element gets oxidized and reduced. And you're going to quote the element. It's Cl, which is plus 4 here. I think it's plus 3 over here. That's getting reduced. And plus 5 over here. That's getting oxidized. And he's asking, deduce the ionic half equations in B1. So you've got this reaction. So you've got to figure out which two equations got added up to form this one. So one of them is the reduction equation, ClO2, right? And that's turning into, I mean, this is, I think, plus 4. And this is plus 3. So one of the equations is going to be this one, the reduction equation, ClO2 minus 1, right? And the other one, so that's my reduction and my oxidation equation. It's again ClO2 that's turning into what? ClO3 minus 1, right? So how many electrons were gained? ClO2 plus 4, 2 plus 3. So that's a gain of 1 electron, right?
1 electron.
And this is a loss of 1 electron. I mean, this 1 electron. Now you need to balance the reduction and oxidation because everything should sum up to give you this, right? So I've got water over here. So the oxygens in this one are already balanced. So I don't need to balance this equation. It's already balanced. The electrons are also balanced. I mean this one is fine, right? I need to balance this one. There's more oxygen over here, 3 oxygens. So what I'm going to do is I'm going to
1 H2.
I mean, whatever is left is probably going to be part of this one, right? Because remember, the left side is going to add up to give you this, right? Do you get my point? And the water, you don't need water in this one. This one is already balanced. So that means the remaining parts would belong to the other one. So there's going to be water over here. So is the second equation balanced now? Like you had 2 hydrogens, that's 2 hydrogens. You've got 3 oxygens, there's 3 oxygens. How many oxygens do you have? 4 over here. Over here you have 1 and 3, that's 4. So that is also balanced, right? Is that clear? You can now so we were able to do the reverse. And then he's saying a lithium electrochemical cell can be used to generate electricity for a heart pacemaker. So there's a lithium iodine cell. Now you've got only one equation for lithium and one equation for iodine in the periodic table. So in this data booklet, that's 1.54. And there's probably just one for lithium in L. I mean, they're close together, I think. It's over here, minus 3.
-3.04.
So this is the one that's going to lose electrons, right?
Yes.
And the other one is the one that's going to gain electrons, right?
Yes.
So I'm sending you this worksheet and try and complete this course. We're not going to study electrochemistry now. You do the worksheet. If you have any questions, then we'll discuss, right? So let's just 1 second. So I'll post this worksheet. Okay, and we'll try and do organic tomorrow. Right, but do complete the worksheet. Just a second. How many pages? It's like do as many questions as possible. It's it's a big worksheet, 67 pages. So at least try and do 10, 15 pages out of this worksheet and scan it and send it to me, right? And if you're looking for answers, the paper numbers are over here, but send the working to me, right? Let's continue tomorrow then. Okay, Rajni. Take care.
So thank you.